Hi everyone, my name is Sarah Drasner. I'm going to be talking about animating in React today. Animating in React is actually like a pretty broad subject matter to cover, so I'm going to be talking for a little bit longer than a half an hour, probably closer to 40 minutes. Thanks to Matt and Jameson for letting me do so. Because it's early in the morning and you're probably all like half asleep, I put these little fire icons on the slides that you probably want to pay attention to, so you can doze off and we'll alert you when you need to be paying attention to stuff. My name is Sarah Drasner again, and this is me as a child and also my relationship to authority. I used to be a manager of UX design and engineering at Trulia in Zillow Group, and now I am a consultant and I work and speak at events like this one. Before we get started getting into the nitty-gritty of kind of like how to do really cool stuff in React and with animation, we're going to start from the beginning. So we're going to deal with some kind of like theory just to get under the hood. So when we start from the beginning, what happens when we visit a website? Basically, when you're looking at something, even if you're looking at a static image, your eye is always scanning over that material. It is always constantly moving around and kind of grokking what's going on. So this is like a heat map of where your eye is looking. So you're trying to create spatial awareness in an event called saccade. And this is important because when we're looking at things, we're never, ever just looking straight at them. We're trying to make a spatial map of what we're seeing. This is an eye tracking just one image. So why is this important? We already use this information all the time. This is part of the reason why websites all start to look the same. We all start to put like logos on the left-hand side and calls to action on the right-hand side, because we're all kind of collectively saying, okay, well, the audience and our users know that that's where they're going to be trying to go, so we're all going to kind of copy each other so that they don't have to create a new spatial map every time. Buttons on a website and CTAs are usually the most powerful thing. They're like bright orange, so they can track your eye movement, and your eye goes there. So you click that button and make your company money. That's the reason why things like growth hacking exist, where people are like, make it purple. OK, no, make it bright green. No, make it pulse. And if you're the dev for that, it makes you crazy. But that's part of the reason why, because you're like looking around in that event all the time. This is also why we do user testing. This is why we're like constantly seeing what collects people's attention, what draws their eye. And because of this, nothing is more important and nothing causes you to look at it more than something that's moving. You are evolutionarily trained as a predator to see something that is in motion as either a threat or possibly food. So you are drawn to anything that's in motion or in movement way stronger than anything else. And because of that, if you do it badly, then it really, really sucks, because you're drawing the user's attention to this thing that's moving around that they don't like. And then animation ends up getting a bad rap. So we're going to kind of go over some things about like how to make things better for people. And one way is context shifting, like being aware of context shifting. So have you ever been in a job where you're working along and somebody comes up to you and they say, OK, we need you to work on this other thing real quick. And then they need you to work on this other thing real quick. And they do that to you constantly through the day, and then by the end of the day, you're kind of like, you might have gotten a lot of work done, but you kind of feel frazzled and frantic even though you were productive. That's because you are moving and shifting your brain to a different context, and it follows that websites work the same way. So this type of like thinking about context shifting can really help with spatial awareness. And this is part of the reason why we need subtlety and consistency when we're working with animation. So if we're looking at something like this pen, and I'm opening this contact here, right? And then the contact becomes the title, and then the email moves out of the way, and then these two become the loader, which then in turn becomes the success. And then that's like the strongest movement through the whole thing. And then when I collapse it, it goes back down. So if I were to say to you later, where is the contact form? You'd say, it's in there. There's no in there. It's just like divs and like inputs and things like that. So, but like for the user, that's really important, that they feel like there's a place that it is, the place that it lives. And the other thing is that instead of popping a bunch of dialogues and a bunch of displays in your face one after another, you start to feel like it's all one continuous experience. You don't feel like you're being jarred in every direction. So another really important thing is things like isolation. If I'm trying to read all of this information at once, it's a little bit too much to grok. But if I kind of allow my users to focus in on the thing that they really need, then they're only creating the spatial map of that one area that they're really trying to focus in on. So that can be really powerful too. Another thing that is really powerful in animation is that it can be informative, like just in this revealing. So this is just like a D3 block that I restyled and animated. So what that block is showing is how many Walmarts are in the US and like how they grew. So it used to be just a static picture. But if I show it progressively and the animation works as like those Walmarts became available in the United States, it's actually slightly more informative in 3 seconds. You actually are starting to see, oh, okay, these came first, this is where those groups came from. So animation can actually be the information. Another really important thing is like perceived load time. Anticipatory cues like this, Viget did this great experiment where they tested like our custom loader, everybody's seen this GIF before, versus a kind of standard loader versus a custom loader. And they found that people were willing to wait twice as long for just like a kind of simple custom loader, because you're just showing them a little bit that you care about them and that it's not just like some broken experience. So that's kind of important too. Like your users are abandoning things if they feel like they're not being paid attention to in those moments. The other thing about it is that for perceived wait time, when we were looking through that first demo with the kind of like thing that opened, there was a minute after I clicked submit where there was an AJAX call to the server and nothing happened. Have you ever been on a website and you like enter your details and you hit submit, nothing happens, and you like hit it a bunch of times because you just gave them your information and you're like, oh, just work, airlines. In those moments, you feel a lot of trepidation as a user, and just a subtle loader can actually signify and make the time not feel as long. Like in airports, I don't know if you know this, but they started building airports so that you have to walk really far to get to baggage claim, and people started feeling like a really high amount of customer satisfaction because they felt like they weren't waiting for their bag as long. Even though they're just walking around. It's kind of the same concept. So I have a little bit of tough love. If you hate animation, it might be because you're doing it wrong. If the animation feels like sugar on top, like if you build something and you slap the animation on later, that's something that your customer's having to wait for or your users having to like deal with on top of working with your material. If you think back again to that first demo, that couldn't have been built after. The animation could not have been put in later. It's built into the custom, it's like part of the experience. So we're going to talk a lot about the right tools for the job today when we're talking about React. So like, maybe don't use a fitness ball to jump off a building. Maybe like that's the wrong job anyway, but like that's not what we're going to talk about. So we're going to talk a lot about tools today. Before we talk about tools, it's kind of important that you understand the difference between DOM and virtual DOM versus canvas, because we're going to be talking a little bit about that. So it's a little bit like vectors versus bitmaps. One of the pros for DOM and virtual DOM is it's great for UI, UX animation. You have things like text and images and things like that. It's great for things like SVG. I'm going to talk a lot about SVG. SVG is awesome because it is resolution independent. So in this animation where it's going through, one of the cool things about it being resolution independent is that not only is it resolution independent on crisp on any display, but it scales within the thing. So the animation is actually scaling within the SVG DOM, which is pretty powerful for responsive dev. So like you can make that any size, and it's going to be totally consistent. It's easier to debug because if something breaks down in an SVG or something in the DOM or the virtual DOM, it's still kind of there. Unlike Canvas, which will typically break down to nothing. That's not the biggest deal ever. We're all used to console logging. Just thought I'd bring it up. One of the cons is that it tanks with a lot of objects, and because of that, we have to really understand performance, and I'm going to talk a bit about performance today. One of the big pros with Canvas is that you can spin up so many things and make really, really cool stuff, and we're going to go into some like 3D-ish kind of stuff today, because it's really good for 3D and immersive stuff, and you can do a lot with movement of a ton of objects. One of the cons is that it's a little bit harder to make accessible. It's not impossible to make accessible, and actually React is really good at helping Canvas become accessible. So that's like a kind of boon for the technology that we use. And it's not resolution independent out of the box. That doesn't mean that you can't make Canvas resolution independent. It means that you don't have to do anything special to SVG. With Canvas, you have to do a little bit more programming to get it to be OK on different pixel resolution. There's a really great egghead.io talk on this. And it's just like 2 minutes long, and it explains all about this. Go check that out. The other thing is Canvas breaks to nothing. So it's a tiny bit harder to debug. We talked about that. I find that when I talk about SVG, people often think, like a lot of developers often think that it's not well supported. I think we just didn't update our frame of reference. It wasn't well supported for a very long time, but now look at all that green. And I would say, like, you can make fallbacks for a lot of SVG stuff, but IE8, like, look at your analytics, you might not even need to be supporting that. One thing that SVG is really good at is narrative. So OK, I made this animation, and Sarah Swedon showed this at a conference and was like, how many introverts are in the audience? And then like nobody raised their hand. It's a really small file size if you design for performance. If you design for performance is a really important one here, but check this out. So here I have this like responsive SVG sprite, and if I make it smaller, it actually changes, and I'm like adjusting what is actually going to be on the screen as it's moving. That whole animation and SVG, everything was 8 kilobytes gzipped. So if you compare that to using text and photos to illustrate an article, that's pretty awesome, especially for something that could be really engaging and like maybe give you a leg up because it's really, really interesting. It's really good for accessibility. Marcy's going to be like the accessibility expert. I am not an accessibility expert, but SVG is really, really awesome because it has navigable DOM. So there's tons of stuff that you can do to make it accessible. There's also a really good resource. That last link is an article that Heather did for CSS Tricks that has just tons of use cases. So if you want to learn about that, there's more information there. So now let's talk about React. The simplest example is something like this. We have a few components. We can see that like the book here is a slightly different color. We had an animation here, and one of these is bigger. So we don't even have to like do a full React component. We can just do like a kind of dumb component, right? And we're like passing some default props, and we've got our width and height and things like books. I called book side and book front, and we're wrapping, like this is really, really bare bones. We're wrapping it in some CSS that we're going to call so that we can animate it. And then when we look at it, we've got like those three components here, and then we've got the switcher class around it that allows it to be animated. And then we've got our default props, and then we can change up icons. Super simple, very easy to work with. I'm not going to talk about React CSS Transition Group that much in this talk. I'm going to talk about other tools because Cheng Lu just like very famously put this in his slides for his React Europe talk. That's a really great talk if you guys are interested. Part of the reason he did that is because he made a tool that's really, really super slick called React Motion, which we are going to talk about. But I do think that one cool thing about React CSS Transition Group is things like enter, leave, appear. All of those things are like one of the best parts of React CSS Transition Group. But I just wanted to alert people that even though those properties aren't available to you in CSS, they are available in native vanilla JavaScript. So if we have animation start, animation iteration, and animation end. And you can do all of this with vanilla JS and work with it however you'd like. I don't even know what that guy is. Sometimes I like make these things really late at night, and I thought he was an owl, but somebody else thinks he's a fish. I'm just not sure. So if we're not going to use those tools, then what? What are we going to use? This is like one of those fire things. If you fall asleep through the whole talk, maybe you wake up for this slide. This is just my recommendations. I work with animation a lot. You don't have to listen to me. You should try things for yourself. But I bang my head on this stuff a lot. And so these are like things I would suggest after having worked with it a bunch. CSS, SCSS, Sass, less. It's OK. It's not that great, though. I think JavaScript has a lot to offer in animation. So it's OK for like small sequences and simple interactions if you don't want to like add another resource. It's very performant, which is nice. But once you get to 3 or more sequences, you should really be switching to GreenSock. GSAP. It's a really, really powerful and performant animation API. It's worth saying that I don't work for them. They don't pay me. I'm going to be talking about how much I like them. I'm just a developer who likes them. Yet I'm not like a marketing scandal or something. It's really good for sequencing and complex movement. I'll go into that a bit. But I would say probably the #1 reason I use GreenSock is cross-browser consistency. I don't have to debug tons of bugs like across the DOM and virtual DOM and also SVG. It does a lot of that stuff under the hood, and it's really performant. I ran tests for all different types of SVG animation techniques and tools and found that GreenSock was just as good as native, which is like kind of amazing. React Motion is beautiful, and it's really, really awesome and really, really fun to work with because it's very, very declarative, and you get to work with it just like you do with a lot of other React components. But what's very different from GSAP and React Motion that you should know is that React Motion is a little bit more like game-based animation, where you give something mass and physics and send it on its way. So it's not time-based. It's not like you don't like fire 2 things at once and they end up at the same place at the same time. You just kind of let it go, which makes it really powerful for realistic movement. GSAP is better for finite control over something that's a little bit more complex. And I'll show you what that means in a minute. When I'm talking about this stuff, a lot of people are asking me, like, why don't you talk about Snap SVG more? Well, Snap SVG actually isn't an animation library. If you talk to Dimitri, the creator of it, he never intended it to be so. It was really meant to be the jQuery for SVG because it's hard to do DOM manipulations in SVG. It does support some types of animation, but he actually prefers and recommends that you use GreenSock. And even in some of those beautiful demos that are on his site, if you dig into the code, there's a lot of CSS animation in there. So just to let you know that. Web Animations API looks fantastic and has so much to offer and will be like GSAP in that it's very sequential and there's a lot of stuff you can do. But we're still waiting on support, and there is a polyfill for it, but the spec is moving, so sometimes the polyfill breaks. So I would say if you want to test it out and play with it, that's super awesome. Maybe don't put it in a production site unless you're the kind of person who likes your tests not passing. Velocity.js is kind of similar to GSAP in that it has that sequential time, but it has a little bit less bells and whistles. And when I did these animation performance things, I found that Velocity actually really didn't perform very well. Those tests, though, were done 1.5 years ago, which is dinosaur times in web years. So I would still suggest that you test things for yourself. Mo.js is super awesome and looks great and is also still in beta, so play around with it. But similar to Web Animation API, maybe don't put it in production yet. And D3.js and Victory.js, I should have mentioned in here, are really built for data visualizations and really good for those things, but they're powerful enough to do other things with also. So I'm going to dig into staggers a bit in particular because there's some interesting differences with staggers. Staggers can actually help you with the performance of many objects. So if you think about if you're animating a bunch of stuff at once and you're basically asking the GPU to calculate all of those, sometimes it tanks a little bit. So if you basically stagger them in a sequence just a little bit, it actually can help the rendering because the GPU has a little bit of time to recover. React Motion is interruptible, which means that if you're moving with staggers in a certain direction, you can actually change directional update mid-swing, which is not always the most vital thing, but it's really beautiful, and I'll show you what that looks like. And I put a little star because that's nice. Same with set timeout. We're going to talk a bit about request animation frame. Set timeout the only like leg up on that set timeout has over a RAF is the staggers. And GSAP has cycle stagger, which I think is super cool. Basically, in these 2 lines of code, I can do so much because we're staggering in between 2 values. So GSAP is going to always like take the value and update the next one. Just like take that animation and update the next one. Unlike React Motion. Oh, one last thing. SCSS and SAS have staggers and stuff that you can spin up with the basic for loops and stuff. And they're really performant, but they're not very good for interaction. So in terms of React Motion, there's a lot of really cool stuff we can do. So when I said interruptible, I mean like we can move it back and forth like that, and it's going to constantly update. What's really cool about this kind of game-based movement, and their staggers in particular, is that what's happening is one is moving, and then the other one is moving and updating based on the last one's placement in time. So instead of it just staggering dun 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 dun, it's like updating, and you're getting the next animation for free, basically. And so you can do things with staggers and stiffness parameters that make it really, really beautiful. So if we're looking at the code for this, again, you can see like one of the really big strengths of React Motion is that you're pretty familiar with what all these things are anyway. That's a very declarative, React-y way of working with animation. We've got a staggered motion component, and basically what we're doing is we're passing styles. So one thing about working with React Motion is that you do kind of have to understand how CSS works a little bit in order to work with it, because it's working with CSS under the hood. And you can see in this like WebKit transform and transform, I'm using these transform translates to move things around. Let me explain why. When we're moving things around, not all properties are created equal. A lot of things like margin left and left cause a lot of repaints, and they end up being very janky. Opacity and transforms are really, really cheap for the browser to do, so you don't have a lot of updates. And there's things that you can do to hardware accelerate. So if you feel sad that you're only allowed to use opacity and transform to move things around, it's important that you know that all of the animations I'm going to be showing you today are being done with just those 2 properties. So there's actually just tons of stuff that you can do with just those 2 properties. In terms of hardware acceleration, things like you probably heard of the transform translate z null hack. And backface visibility hidden and perspective 1000 all let the GPU know that this is going to be hardware accelerated. You can also do this thing called will change, which alerts the browser to the property that's going to be changed so it can kind of get ready. So there's more information about those 2 things here on jankfree.org by the Chrome Dev Tools team, and I wrote an article about it as well. So if we're looking at this kind of stuff and trying to debug it under the hood, you can kind of see in that top one that it's like jittering around. Maybe you can't see as well on that display, but on mine you can kind of see. So if we're going into Dev Tools here, you can look over here and then say stuff like rendering settings. And then if I highlight paint flashing, a big green rectangle is going to come up for the first one. The reason why the big green rectangle shows up is when you aren't properly moving things or hardware accelerating. So that's a really good way of debugging animation for people who aren't used to doing that. If you don't believe me, Netflix, there's a case study for how Netflix does hovers, and Netflix does use React, and I think there's some Netflix members in the audience. Hi. And they use transforms and opacities and do it the correct way. So now we got done with all the theory and some of the tooling stuff. Let's make some cool stuff. So we'll start it here. So I made a video game with React. It's just 2D side-scrolling video game, kind of like Flappy Birds. It's about an elephant who's a hipster who wants to go get tacos, but his friends keep texting him to change plans. It's based on real events. So if he gets hit by, you can see that like heart meter at the top. If he gets hit by the text message, then he kind of gets lower points, and if he gets the tacos, then he gets better. And I'm going to wait until I get the margarita. The margarita is like a special thing. So, and you can like win and lose, obviously, if you get high enough or low enough. So, um, we're actually not using, we usually use Canvas for games like this, but I wanted to use React and SVG and GSAP and things like that to create this, just to see if I could and see like what we can learn here. So how do we use SVG here? We used it 3 ways. We used it directly inline in the HTML for loops. When we didn't need React to do stuff, we didn't use it. So anything that was like those clouds that were moving consistently across, we're just putting those on the page and moving them instead of having React render all of them, because it does cost a little bit more to write all of those components. The background images for things like Taco are just background images like you're probably used to using, like just image source, SVG. And then the cool part is that some of it is inline in React, and I'll show you why. So if we're looking at the app and we have the get initial state of score 500, we start with like a bit of score. We also have like start game, because we're going to recall start game at the beginning, and when people win, we restart that game for them. I'm not showing you all of the code here. There's too much code to show. We also have update score so that we can check if people have won or lost. And the most important thing here is that we have this heart meter component where we're passing this.state.score. And if we look at this heart meter component, we have inline SVG with a width that shows this.props.score. So what's really cool about SVG, because it's drawn with math, is you can do things like update a score and it will actually move for you. So if we have just like a simple rect here, you can see in this rect that we just have 4 attributes that like cause it to be rendered. An X value for where it is on the grid, a Y value, and then a width and a height. So if I change this to 150, it gets longer. So that's basically how we're updating the score. And I made that heart meter really big so that it was actually the direct units that we're using. It's going to be 500 wide. It's not 500 on my screen, but because it's SVG, it's scalable vector, you can just collapse it to be small, and then it's updating exactly for the amount that you need it. So how do we animate things? 4 ways. We use GSAP in GreenSock in looping and functions outside React. We used request animation frame or RAF to detect collisions, GSAP for key press events, and repeating callbacks for tacos and margaritas. So let's dig into that. So request animation frame is super awesome. You probably have heard of it, but in case you haven't, we'll talk about it a bit here. Get bounding client rect is a native method that you can use to return values like left, top, right for things in the DOM. So we're going to use that to kind of figure out where things are and then check if it has intersected. And RAF is running on a continual loop. And then we're just going to call a function every time that happens. And then we have request animation frame that calls itself again. So what is request animation frame? We're using it instead of set interval and set timeout. It's more performant than that. You can find a polyfill in NPM, but it's a really small amount of code. You don't necessarily have to use NPM to use it. It's really declarative because before request animation frame, we were using set interval and set timeout and having to figure out the time delta that was different between desktop and mobile rendering settings in order to make it performant and not tank. So request animation frame does all of that for you. You're not having to figure that stuff out, and it's just going to automatically kind of find the best performance and run it as quickly as it can for the device that you have. Basically, the way that it works is that before it draws the next frame, it executes some logic. And what's really cool about it is that when you're not in that tab and you're not using it anymore, it just kind of stops what it's doing, and it understands that it shouldn't keep running forever. So what's really cool about that is you don't get the Chrome angry face and the tab dies when you're not using it. It's really, really good for maximizing perf on inactive tabs. I'm really interested in how things work under the hood, so I wrote a lot of animations just using request animation frame and spinning up SVG. I rewrote other people's animations just to figure out how it would work. That's in this JS Stroll repo if you're interested. One of these was a particle demo. So I'm just making these SVG things that I'm kind of creating as it's moving forward. And again, like if we're looking at a circle in the SVG DOM, we just have 3 attributes that draw this, a CX, a CY to plot it on the C kind of, this is gonna move it over by 50 pixels. And this will move it over to 150. And then it's just a radius. So I can make it like way bigger and I can make it way smaller. So it's pretty simple to create and update circles and things like that. So what we have, and I'm not going to show you all the code here, but I'm making things like acceleration and distance and velocity and all of those things. And then I'm just updating the circle on that set attribute to the CX and CY, and you can see how that would update them and create those things. By the way, this is a lot of how D3 works under the hood without the data binding. So now you know how D3 works, and maybe you don't even need it. Another cool thing about it is it's a really easy call. You're just basically like calling it in an IFI, and then you're going to have this request animation frame animate. It looks similar to recursion. It's not actually recursion, but it looks similar and works similarly to recursion. Another way that we worked with it is GSAP for animation. So we have this function here called flyby, and I'm passing a bunch of params. And first, I'm going to check if the game's over or not. I don't want to like run this if it's not playing. But the interesting part here is this callback that's basically a pointer. Again, looks like recursion is not. It's a callback to a pointer to this function again, and I'm passing in those onComplete params so that I can do all of the tacos, margaritas, and text messages with the same function. So GreenSock has a cool syntax. I am really terrible at live coding, so I made this monster to live code for you. So he's going to show you a simple tween. This is just like how an eye kind of like opening and closing, and then antenna. And you can see how like really, really simple and small the code is to do a bunch of cool stuff. So then if I have a simple timeline, I can like add it to the timeline, or I can wrap it in a function and be a little bit more responsible about it and add it to a master timeline, which is super cool, because then I can have 2 functions, and then I can really start to like get into some complex movement where I can understand timelines a little bit further. And you can see that they're following each other now. They're not all going at the same time like that first tween max. And then he's going to say goodbye. Bye. So one of the really cool things about GSAP is it solves cross-browser inconsistencies. Some of these bugs kind of like get fixed over time, but that IE not working and not moving at all is just like, that is a thing. IE does not support transforms on SVG, so if you want your code to work, you use GreenSock. There's more in that CSS Tricks article. I also really like the timeline. This is super powerful. You can stack tweens, set them a little before and after another, change their placement in time, group them into scenes, add relative labels, animate your animations. That's super cool. Make the whole thing faster just with 1 line of code, all without recalculation. And this is really like the hardest and yuckiest part of CSS animation, aside from the fact that it is a little bit more code to do the same amount of stuff. If you have 2 things firing at the same time and you have a bunch of delays because of sequences, and you have to change the timing of one because it doesn't look quite right, you have to go back and recalculate all of those values on either side. That sucks. When I say stuff like that, it kind of sounds like I'm being picky, but I've never done a longer animation where I haven't adjusted the timing because some little thing looked off. So this ends up saving you a ton of time. In order to illustrate the timeline, I made this. So I made an initial just kind of animation where it's like popping, and then it does a couple of things. So I actually fire that popping animation function a couple of times on the timeline. There's no GUI for this. I'm just kind of showing you what it looks like in like a visual representation. And then you're firing the next function that exists here on the timeline. And I built this for you, so I probably don't need to narrate it. So I can actually just change the order of those functions by changing where they are on the master call, right? So I'm just switching the order, and then the whole thing runs in reverse. Or like I said, I can change the whole timing of everything in one line of code. Now, that's super slick. That's awesome. So that stuff makes it really, really fun to work with for complex animation. So if we're looking at the hit test increase, so this is like every time you get like a taco that passes by, it like goes blink, and like you get your heart, your heart update score is happening. So you have this like, if you're checking first of all we're like setting a flag with state to check, because remember when we're working with RAF, we're checking constantly if they're hitting, and it's going to hit for a really long time. So we don't want it to continually fire. We want it to fire just that one time. So we set it up here, and we also check if it's playing or not. We're also like declaring that we're going to use a timeline here, and then we have the audio increase play. That's the ba-doom. And then we have our first timeline here. When we're working with a timeline that repeats, we're going to use a from to, so that it always starts from where we need it to, because who knows where it was last time, right? And then we go to the next timeline. And then on the last thing, we're setting that taco pass to true, and then somewhere else we set it to false again once it's completely passed by. That way it's not continually blinking and running and things. And then we also set this.props update score, so we can update the score by 75 points. So why didn't we use React Motion? I said that it was game-based animation. That seems like a perfect thing for this, right? Well, React Motion is slightly more verbose by maybe 5 or 6 lines of code per one of GSAP. So when you get to something like super complex, it ends up taking a lot more time. And remember, again, we're using CSS. So there's some things about CSS, like the cross-browser inconsistencies, that are a little bit more stable in GreenSock. There's no way of writing a loop without writing an infinite loop in React Motion, which is bad. Don't write infinite loops. One more gotcha is that staggers can't create arrays with new numbers of objects. So React Motion is super powerful and really awesome, but use the right tool for the job. Here's a couple of cool things that you can do with React Motion. So here's like a responsive thing here. And when I'm working with it, I can update all of these little circles and make these kind of cool things that open and close here. They stay consistent for all of them. Oh, and we have these slidey kind of fun interactions here. So if we're looking at this, we're basically again, we're using the previous ones to update the next one's placement, and we're doing just basically a ternary operator check to see if it's open or closed. We have all of our path data in an array, just simple path points. And then when we have inside that circle, we have a staggered motion component. And we're passing the styles down here. You can also see that we have, wait, no, that's not what I was meant to do. We have our key. That's so that React can make sure that it knows what it's refreshing and what it's updating. And we have all of our path data here. And we can also add things like class name. And that style opacity is actually what React Motion is using. So we can also do cool things like draw text onto the page with React Motion. Super awesome. Under the hood, it's like this. It's done with stroke dash array and stroke offset. So if you have a shape, you have imagine you have a dash around that shape. It has a stroke and it's dashed. We can use JavaScript, a native method, to get total length of that path. And then we'll dash array the entire length. So basically, that small dash becomes the length of the entire shape. And then we can animate dash offset, which is an animatable property. So you can do something like this. So for that last pen that you saw, when we're using React Motion, we're basically, checking in that JS get total length, it returned the highest value was 200. So we've got it here in 200. And then we're just animating that stroke dash offset, and then it updates. So that's super cool. GSAP also has super awesome things for drawing SVG with the same kind of technique. So you can do percentages to percentages, integers to integers. You can make it collapse. You can do Booleans, lots of cool stuff. So that's really interesting to look at. Last couple of things, I've been talking for a while, we're almost done. Last couple of things that we're going to talk about really, really quickly is Canvas. React Canvas is great. It was created by Flipboard to get to 60 frames per second animations, but it was mostly meant for UI and UX, so like things like text and images and kind of standard web element kind of stuff. React Canva is meant for creation of pixels, so spinning up like beautiful, awesome things. It has really, really nice declarative syntax, which I'll show you in a second. The API animation for this is a little bit janky, and they even say in their README, like, we didn't build the animation for performance, so you might want to use something else to animate it. And you can write Canvas directly in React. That's one of the coolest things about React is you can use it for like almost anything. So here is React Canva, so I'm just like hovering over these. But I wanted to bring this up because check out this syntax here. I'm basically making all of these stars really, really easily with the number of points if I just want to update that. Then I make these like crazy looking stars. And I can change this to, like, look at how declarative that is. That's so awesome. So it's, you know, and you can do these things like fill this.state.color. I just think it's a really cool tool, so you might want to check it out. React in VR is really fun. I've been playing with React VR in A-frame. So this is like another really simple and declarative thing. So I'm just like moving around a bunch of things and spinning it up. I'm still like learning this stuff, but it's so fun. It's so awesome. If we're looking at some of the code here, check this out. This entity geometry, there's a bunch of code that you're not seeing here, like calculating all of these random positions and stuff, but you can see how declarative and simple it is to spin up a lot of items, and then I'm just using them right here. So that was really like a small amount of code for a really cool effect. I think social coding sites are awesome, and they really help me learn, and they probably help you learn too. My favorite one is CodePen, and you know, we have all of these Soviet, like Russian designs that are super awesome. So here's a like CodePen propaganda poster in that same kind of propaganda way, because in Soviet Salt Lake City, Utah, the CodePen is loaded with you. I gave a front-end master's course on advanced SVG animation. This doesn't have a ton of React stuff in it yet, but I'm going to be giving another one soon that will have more information about that. I'm also writing an O'Reilly book that will have a lot about React in it. This is not the cover of that book. This is my friend trolling me super hard with a man blob animal, which I don't think I have, and that's not even my last name. This is the actual book. I think I got a fancy chicken. Yeah, that'll be coming out at the end of the year, and thank you.